Okay, now this is going to serve two purposes today. One is going to be that recording we need for the students who got an incomplete and want to make it up next week. And then two is going to go over the homework for week 7. But before we get started, does anyone have any questions?
No.
No one? Well, hello, Kashan. Okay, let's get started. Now, if you were in class in the building yesterday, you've seen some of this. But I'm going to go over it just to make sure that we're all on the same page. Okay, in Algebra 1, you worked with systems of equations that have 2 variables here. This year, we're going to work with systems that have 3 variables. Now, let me share this with you. Okay, can you see my camera now?
Yes.
Okay. So these are a couple of terms we need to get out of the way here. It looks like I've got a glare from something. That seems to be a little better. Okay, one of the terms you're going to hear is going to be Gauss elimination. Now that refers to a row echelon form of a matrix. If you hear the term Gauss-Jordan, that refers to a reduced row echelon form. And the difference is this. If we have a 3 by 3 matrix, this is a 3 by 3, that means we have 3 rows, and rows go horizontal this way. So we'll call this row 1, and it might have 1, 2, 3, and row 2 might have 4, 5, 6, and row 3 might have 7, 8, and 9 in it. The 3 refers to the rows. The second 3 refers to the columns. So this is column 1, column 2, and column 3. Now, a row echelon matrix looks like this. And we abbreviate that REF. It has 1s on the diagonal. And everything in front of the 1 is a 0. Doesn't matter what's behind it, but the 1 has to be on the diagonal. And this diagonal is called a pivot. And zeros have to precede it. Now, if you get a matrix that looks like this, a reduced row echelon, it still has 1s on the diagonal and zeros in front of it, but it also has zeros behind it. Now that's the difference. This is the Gaussian elimination. This is the Gauss-Jordan elimination. Now we're going to work with this one, because once we get it like this, we can do back substitution and solve the rest of it. Let me zoom out a little bit. And that is not working. So suppose we have a problem like this. Let me pull something up here in Schoology. Okay, can you see this window here?
Yes, sir, we can see the practice problems.
Okay, I'm going to work one of those. Now, in these practice problems, you're going to be looking to solve a quadratic. Remember, a quadratic looks like this. Y equals ax squared. Let me write the problem down, then I'll switch back. So I'm going to do an ugly one. I'm going to do E. 2 and 35. 5 and 167. And 8 and 425. So I'm going to switch windows again. And go back to Ladybug. So these are my 3 points. My quadratic looks like this. Ax squared plus bx plus c. Now in this ordered pair, the first term component is x, the second component is y. There's 2 of them, so it's called a pair, and the order matters. X comes first, so it's called an ordered pair. Now, we can use that because these are values of x and y to write equations. So let's write our first equation. We're going to use this first point here. We know the y value is 35 and the x value is 2. So this becomes 35 equals a times 2 squared plus b times 2 plus c. And we don't know what c is. So this equation becomes 35 equals 4a plus 2b plus 1c. And for the second point, again, this is x and that's y, but we have a different x and y. So 167 equals a 5 squared plus b times 5 plus 167. And if I clean that up, I get 167 equals 25a plus 5b plus 1c. And now I'm going to do my last point. X is 8, y is 425. So 425 equals a times 8 squared plus b times 8 plus c. So 425 equals 64a plus 8b plus 1c. Okay. Now, as I said, I'm recording this, so if you're taking notes and you get a little behind, just go back and look at it later. Now let's set this up in a matrix. Now I have 3 equations, 3 rows, row 1, row 2, row 3, and I have 3 variables. So those variables become my columns, A, B, and C. Row 1, row 2, row 3. Now I only want numbers in my matrix, so I'm going to take the coefficients, 4, 2, and 1. Down here I'm going to get 25, 5, and 1, and then 64, 8, and 1. Now you might ask, what do I do with these y values? Well, they're going to get their own matrix. So I'll have a 35, a 167, and a 425. Now this matrix here has 3 rows and 3 columns, so it's a 3 by 3 matrix. This one has 3 rows but only 1 column, so it's a 3 by 1 matrix. Now I'm going to multiply these. Now if you're going to multiply a matrix, this inside dimension here has to be the same. 3 here and a 3 there. If I had a 5 here and I wanted to multiply, I'd have to have a 5 here. Doesn't matter what the other numbers are, but these inside numbers have to match. Now we're going to solve this using a calculator. So I'm going to stop presenting and go back to the calculator. Okay, so I've got my RAM cleared here. So I'm going to go to Alpha, Window, and I want this matrix button here. That's going to be my zoom button. And then I have to tell it what size matrix I want. Well, remember, my matrix is a 3 by 3. So I'm going to have to move down. We're using the button. Oh, that didn't work. Why am I not doing this right? Okay, I've got the matrix. Should be able to move down.
You have to move up.
What was that again?
You have to go up because it starts at OK.
The up key?
Yes.
You think so?
Yeah, and then keep going up.
Wow. Who said that? John?
Yes.
Well, John, you just got an extra point, young man. Let me write that down.
Thank you.
What class are you in, John?
Virtual.
Which one?
Virtual. I don't know which
are my virtuals? I have two. VO2 or what?
I have V15.
V15? Okay, I made a note, but don't let me forget. Well done, John. Well done, young man. So I'm going to go up to 3. Enter that. Move over here. Let's see if John's solution works. Nope, didn't work there.
You have to go to the right now.
Oh, John, you know so much here. I am so impressed with you, young man.
Down.
What happened, John? Now I got to go down. Okay, John. So this is a 3 by 3. So I'm going to click OK. Now, how do I click the OK, John? Hit the enter button.
Go back down and then you have to hover OK. And now enter.
Okay, guys, you see who we have to talk to when we get someone like this. Now I'm going to put my numbers in. Do I need to go back to the screen and show you what they were? Yeah, I think I better. So I will go back to.
We could tell you what they are.
Oh, you know what they are?
Yeah, I wrote them down. Yeah, me
What did
too.
you write down?
The numbers you wrote. The example you were
Well,
showing.
what were they?
Okay,
4?
well, for the first row across, 4, 2. Under A is 4, under B is 2, and under C is 1.
Okay. I like this participation, guys.
Are you ready for the second row?
No, I can see what they are. I was just checking on you. Sometimes you guys might doze off on me. You never know. Okay, then 64. 8 and 1. Now, we didn't talk about matrix theory that much, but we can't use this matrix. We need what's called the inverse of a matrix. So to get that, I move my cursor outside the matrix, and then I come to this key here. Can you see this one? X raised to the -1? Well, that means X inverse. And that puts the -1 here. Now I've got to put my Y matrix in there. Well, that's called an augment if I put it both together. So I'm going to go back to matrix.
Nothing showing.
What?
We can't see your calculator.
We can't see your calculator anymore.
Oh, well, that's not good. Let's go to the calculator. Can you see it now?
Yes.
Okay. So we're going to press alpha, window, and then zoom, and that gets me back over here. Now I want a 3x1 matrix. I've got my 3. That's not what I want.
You got to press the up arrow again.
The up arrow? You guys are just stuck on this up arrow, aren't you? Okay, I want 3.
Yes.
And then I want a 3x1. And now I need the OK button. How do I get the OK button, guys?
You got to go back
Space
down.
Yeah, it's always that, isn't it? Okay, let's see if this works. It did work. You guys are so clever. You must be pre-AP. Okay, 3, 5. I'll space over 1, 6, 7. And what was the last number? 4, 25. Now I'm going to space outside the matrix. Now, some calculators you don't have to space outside. And if I press the enter button, I've got the answer. And this is my answer. 7, -5, and 17. So I'm going to go back and show you the camera again. The camera is called Ladybug, guy. So I'm going to write my answer here. Y equals 7x squared minus 5x plus 17. But now I need to check my answer. So if I take this equation here that I just wrote, and I plug in these x values I was given, I should get the y value I was given. So to do that, we're going to use the calculator for that. So I'm going to go back to the calculator. I'm going to go into the equation editor. Now that's what we call y equals, but we'll go there. I'm going to put this in 7x squared minus 5x plus 17. And then I'm going to look at the table. So second graph. Now my points were 2 and 35. And this is not right, guys. You sure we didn't write something down wrong? Well, let's go back and check it. 7x squared minus 5x plus 17. 2 and 35. 2, 5, and 167. And 8 and 425. That looks good. 421, 25, 5, 1, 64, 8, and 1. What did I put in there? Let's go back and look at this again. Three by 3. Let's check this out. I want the matrix in here. So 421, 64, 8, and 1, 35, 167, 425.
That's right.
What was that?
Your equation is right.
Oh, you checked it?
Yeah.
Well, did I enter it incorrectly here?
Well, you should take that away if you put it. Yeah.
Okay, I put in 7x squared minus 5x plus 17. Let's graph it first.
It doesn't show up on the graph.
Oh, it's too large outside the parameters. Let's look at the table.
It's right, 235, 567, and 84.
What happened before?
I think you were just looking at 1 instead of 2 or something.
Well, why didn't you say something, John?
Um,
Remember that point you earned, John?
what?
You got to work to keep it. Okay, now I got to give you 2 points, John. You're killing me here. Okay, now even though I messed up that chart there, does everybody get the idea here? Should we do another one?
Can we do another one?
Let us do another one. So let me clear this. 7, 1, 2. How many of you have a calculator?
I have a
Sean,
calculator.
you have one?
I have 1.
2 people?
3 people.
Okay,
Yeah,
let
I
me see
got
if I
one.
can find an online calculator for you to use. I thought I sent out an email at the beginning of the year telling you what a few of them were. Okay, let's pick another one here. Which one did we just do? E?
Yes.
Let's do C. So C, the points are 3 and 43. 4 and 61. And 11 and 299. So I'm going to switch back over the Ladybug. And those are my points. So let's write the equation together. First equation, y is 43, x is 3, so that's 3 squared, plus b times 3 plus c. So 43 becomes 9a plus 3b plus 1c. Everyone get that?
Yes.
Second equation is 61 equals a, x is 4, and that's squared, plus b times 4 plus c. So this becomes 61 equals 16a plus 4b plus 1c. For the third equation, we have 299 equals a 11 squared plus b times 11 plus 1, well, I'll just call it c. So this becomes 121a plus 11b plus 1c. And now we're going to write our matrix. Again, we have 3 rows, 3 columns, one for each of the variables. So this is a 3 by 3 matrix. And I have 9, 3, 1, 16, 4, 1, 121, 11, and 1. Now my matrix for y is going to be a 3 by 1 matrix. 3 rows. First row is 43, 61, and 299. Okay. Any questions so far? Everyone's good? Okay, let's
Yeah.
put it in the
Yeah.
calculator. Question? Was that you, Miss Garcia?
No, I said yes because everything's
Oh.
good.
Okay. So we're going to the calculator now. And we're going to put our matrix in. So to get to the matrix menu, I press the alpha key, the green key, the window key, and I want matrix, that's this, so I'm going to press the zoom key. If you were looking at a calculator, the zoom key would be right under this. And then I'm going to go up till I get to 3. John taught me that. I'm going to go over. I'm at 3, so I'll enter that. Then I'm going to go down to OK. And now I'm going to enter my data. 9, space over, 3, space over, 1, space to the second row, 16, 4, and a 1, and then 121, 11, and 1. Now let's double check that. 931, 1641, 121, 11, 1. Now to get the inverse, I have to space out here behind the matrix. So I'm going to space out there and press the inverse key. Now that takes care of my main matrix. Now I have to get my Y matrix in. So I'm going to go back to alpha, window, zoom. Now this time I want a 3 by 1, so I'll start to space up to 3, then over, and up to 1, then I'll space down to OK. And I'm going to put in 43, 61, and 299. And then I'll space over, press the enter key, and it looks as if my answer should be 2, 4, and 13. So now I'm going to go to y equals and put that equation in. It's going to be y equals 2x squared plus 4x plus 13. So I'll put in 2x squared plus 4x plus 13. And when I get that, I'm going to look at the table and check my numbers out. 3 goes with 43, 4 goes with 61, and I'll have to space down for 11. And 11 gives me 299. So we have a good system here. Now, if you were writing this on paper, let me show you how it should look. This is called a matrix equation. You see the way I wrote it? I put the equation in, then I showed it was going to be the inverse times this one, and that was the answer. And then I have to take this data and translate it back into an equation. Any questions over that? Everyone's good?
No. Yes.
Yep. Okay. Now let me show you something else here. Now, this is part of a PowerPoint. So I'm going to copy this down, x plus 2y plus z equals -2, and 4y minus z equals 1, and 3x minus 2y minus 2z equals 13. Did I write that correctly? X plus 2y plus z equals -2, 4y minus z equals 1, and 3x minus 2y minus 2z equals 13. Okay, now I'm going back to Ladybug. And this is the system I just copied. Now notice something. I'm missing something here. I should have 3 variables in each row, but I don't have an x. But I can't make a matrix unless I've got something there. So I'm going to put a 0x here. And now my matrix will look like this. This equation here is my row 1. I've got 1 for x, 2 for y, 1 for z, 0 for x in the second, put a plus sign, 4, and a -1. Now that sign makes a difference. 3, -2, -2. I want the inverse of this, and then I'm going to multiply it times my y matrix. And then I will get a 3x1 matrix out of that. Now remember, this is a 3x3. This is a 3x1. So I multiply this out, and what I end up with is that. You have to have these match to multiply, and your product is going to be these two, a 3x1 matrix. So let's put that in the calculator and see what we get. Is it? Oh, there it is. So I'm going to clean my calculator up before I start. 2 plus 7, 1, and 2. Okay. Now to get to the matrix menu, I press Alpha, Window, and Zoom. And I'll need a 3x3 to begin with. And my numbers become 1, 2, 1, 0, 4, -1, 3, -2, and -2. I'm going to space outside, double check my numbers, 1, 2, 1, 0, 4, -1, 3, -2, -2. And I'm going to take the inverse of that, and now I need my y matrix. I'm going to go back to Alpha, Window, Zoom, and I will space up till I get to 3, and then up to 1, and down to 0. And I put in -2, 1, and 13. Now let's double check our numbers one more time. 1, 2, 1, 0, 4, -1, 3, -2, -2, -2, 1, and 13. And this should be my answer. 2, -0.5, that's really -1/2, -3. Now let's check ourselves. Let's go to y equals, and we'll put in 2x, squared minus 1/2 0.5x minus 3. And if we look at the table, we should get, okay, what did I do? Oh, okay. Where are my numbers? You know, that should solve these equations here. Let's see if it does. I'm gonna do it somewhere another way. Yeah, I'm checking the wrong thing, guys. Let's exit out of this. Now, if we plug these numbers back into our original equation, we would have 2. Well, I'm going to let you guys check it. You guys know how to check this? Do you?
Well, you would just put the values in for X, Y, and Z, right? And then if it's
Yes.
equal to, okay, yeah, that makes sense.
Yeah, I was thinking of something else here. So what you would do is go back to this equation here. We know that X is 2 plus 2 times negative 0.5 minus 3, and you should see if that's equal to negative 2. This becomes 2 minus 1 minus 3, and that does equal negative 2. So you do the same thing for each of these to check them. Okay, there's not much to be learned from checking it there, so we'll let that go. Do you need to see another like that, or is one enough?
No, that's good.
You sure it's good? Well, let me show you one of these word problems. So Raymond is packing 42 books in 3 crates to be shipped to college. He has a blue crate, a green crate, and a red crate. The blue crate and the green crate together contain 29 books. The green crate and his red crate contain 25 books. And we need to find out how many books are in each crate. Well, if you're doing a word problem, what you're looking for are 3 different things. You have to have 3 equations here. And in this case, let's write about it. I need one more screen. I'm going back to Ladybug. So we know that he has 3 crates. He has a blue crate, a red crate, and a green crate. And he packs books into each of those, and the total number of books that fit in all 3 is going to be 42. But in his blue crate and his green crate, he gets 29 books. And in his green crate and his red crate, he gets 25 books. Okay. And what goes here in the middle? A 0. And a 0 here. So this matrix becomes 1, 1, 1, 1, 0, 1, 0, 1, 1. This becomes 42, 29, and 25. Now, word problems can be a little confusing if you lose track of what you're doing there. But did anyone have trouble following what I did?
No.
No.
Sydney, did you follow that?
Yeah, I'm good. I understand.
Okay, Kashan, you with me? Yep. It sounds like a yes, Kashan. Okay, Janaya, are you there? Are you Janaya? Well, I'm going to assume that you are. Okay, let's work this one out. So I'm going to stop presenting that, go back to the calculator. I'm going to clean it out a little bit, so I'm going to reset second plus 7, 1, and 2. Now let's go to our matrix. What happened? Three by 3. That's okay. Now my numbers become 1, 1, 1, 1, 0, 1, 0, 1, and 1. So 1, 1, 1, 1, 0, 1, 0, 1, 1. Okay, so we're going to do the inverse of that. And our second matrix, which will be a 3 by 1. And our numbers are going to be 42, 29, and 25. So let's check our numbers. 111, 101, 011, 42, 29, and 25. And our solution becomes 17, 13, and 12. Now be careful the way you write this because it has to follow the order of your original system. So that's 17 blue books, 13 red books, and 12 green books. Now let's go back and check to see if we got that correct. So I'm going back to Ladybug. Now, if this is true, 17 plus 13 plus 12 should equal 42. Does that equal 42?
Yes, it equals 42.
52 or 42?
42.
I don't know what you said. Okay, let's go to the second. 17 plus the green, which is 12, should equal 29. And it does. And for the last one, 13 plus 12 equals 25. Now that's not bad, guys. That's pretty easy to do. Now, if you sing this for the first time, it's a little intimidating, but once you work 3 or 4 of them, you'll be fine. Now let's go back and pick one more. So we'll go back to the slideshow, or the PowerPoint anyway. Now these are cookies. Let's see what the other one is. Polishing machines. I don't know. Cookies might be a little bit more interesting than polishing machines. Let's do the cookies. So we have 3 boxes of cookies. The boxes are labeled A, B, and C. Box A and B together contain 35 cookies. So first equation, excuse me, is A plus B equals 35. Box A and C contain 28. So A plus C contain 28. And B and C contain 37. So A plus B is 35, A plus C is 28, and B plus C is 37. So this is our matrix. Let's fill this in. So if we draw a 3 by 3 matrix, we're going to get this: 1, 1, and 0, 1, 0, and 1, and 0, 1, and 1. The Y matrix is 35, 28, 37. So this becomes our matrix equation. And we just have to find the solution matrix here. Any questions over the setup on this one?
No.
Okay, well, let's get out of this. Stop presenting. And we'll go back to the calculator. And once again, I'm going to clear my calculator. Second plus 7, 1, and 2. So I need a 3 by 3 matrix. So alpha, window, zoom. Space up to 3, over to 3, and down to OK. So my number becomes 1, 1, 0, 1, 0, 1, 0, 1, and 1. Now, check your numbers: 1, 1, 0, 1, 0, 1, 0, 1, 1. We'll make that the inverse. And now we need the Y matrix. So alpha, window, zoom. And we want a 3 by 1 here. So my number becomes 35, 28, and 37. Let's double check our numbers: 110, 101, 011, 35, 28, and 37. So the answer should be 13 of A, this is A, 22 of B, and 15 of C. Now notice this has to be in the same order as you wrote the equations. Let me go back to Ladybug for a moment. So we went A, B, C, so we have to come down A, B, C. Now we just have to check those. We had A plus B, and that should equal 35, and it does. Then A plus C is 15, should be 28, and it is. Then B, 22, plus C, 15, should be 37, and it is. So that's your solution. Now, let's talk about how you're going to write your answer. One of the things that you're going to find going forward from where you are now is that when you work a problem, you got to check your work, and then you have to state specifically what your answer is. You can't just write numbers on the paper and think the teacher's going to know that's your answer. So you have to write a conclusive statement telling me your answer. Therefore, the solution and you can write this several ways. You can write it as a triple pair, an ordered triple rather. 13, 22, and 15. So you could write it that way. It's concise, it's neat, I know what you mean. Or you could write it out. Now, if you write it out, you're going to have to reference back to these statements we had here. Where are they? You're going to have to write, therefore, box A contains 13 cookies. Box B, and you can't do these dittos like I did. You got to write it out. And box C contains 15 cookies. And then you're done. Okay? Well, like I said, don't do the ditto. You got to write box 3 times, and contains 3 times, and cookies 3 times. Because you're young and you need to develop good habits. Okay, I think that's about all I needed to show you here. Let's talk about something else here. Lost my PowerPoint. I guess I don't need to talk about that after all. Okay, do you guys have any questions?
No, sir, no questions.
No.
Kashan, any questions?
No.
That was John, that wasn't Kashan.
Oh, sorry.
Kashan, are you there? Not really. You're not really there, you have no questions. Oh, okay. Armani, you good?
Yes, sir.
You can type your answer if you want. Charisma?
I'm good.
Janaya, are you back yet? Miss Prentice? Well, maybe not. Alucci?
I'm good.
Did I say your name right?
Yes.
Oh. Okay, Jocelyn?
No question.
No questions. Ahmed?
No questions.
And Sydney?
No questions.
Okay, well, I guess we'll wrap up here. Well, it's about time. It's 12:54, so we finished a couple of minutes early, not too early though. Okay, now I'm going to post this on the Schoology page, and then I'm going to put your assignment up. Now, guys, if none of you got an incomplete, you've got to pass on the assignment. But if you want to do it, I'll put it in the grade book, only if you do well. So how do we define doing well? Is that 80 and above, 90 and above, or what?
What'd you say?
Okay, if you did not get an I, you don't have to do this assignment. You got to pass on it. But if you want to boost your grades and you take the assignment and you do well on it, I'll put it in the grade book for you. But we have to define what well means. I mean,
Is
is
well
it 80,
80,
90, or what?
75?
85?
85 probably. That's probably
So
well.
60.
80 what?
85 and
So 85 and up goes in the grade book. Anything under 85, if you didn't get an I, it's just going to be an excused grade. Is that your understanding?
Yes, sir, that makes sense.
Now, if you got an I, and this is the way the principal explained this to me, if you got an I, whatever grade you make on this assignment is probably going to be pretty close to what you're going to get for your 6 weeks grade. The state of Texas gave Aldine a waiver, so they have to have their UIL grades in. They gave them 10 days, it used to be 5, I think, but they stretched it out to almost 2 weeks. So if you're on a UIL activity and you did not get a passing grade, you got an I, this is your chance to fix it. I don't think there are very many people in your class that applies to, but there may have been 1 or 2. Okay, guys, and we'll stop here, and I guess I'll see you guys one day next week. I didn't realize you only came one day until I started looking at students last week, and then I realized it.
We came yesterday and today.
Say it again, Charisma.
We came yesterday and today.
I didn't hear that.
We came yesterday and today.
Maybe you should type it so I can read it in the chat box.
There was a meeting yesterday, and we went to it.
So we've met twice this week. We've met today and we've met yesterday.
Oh, I don't mean that. I mean in class. You know, where you're sitting here and I can look at your face, but that's only for in-class students. It's not for the virtual students. You're fine. We're supposed to have 3. You're supposed to complete 3 assignments. I'm sorry, 5 assignments a week. But if you watch a video, that's 1 assignment. If you watch 2 videos, that's 2 assignments. So the way I'm doing this is I'm looking at the number of videos you watch and the number of assignments you actually turn in for a grade. As long as that combination is 5, you're fine. Now, if it's less than 5, they're counting those as NGs. Did you guys know that?
Yes.
Oh, well, that's good. But I don't think that's much of a problem with our pre-AP students. You guys are pretty diligent. Okay, enjoy the rest of your weekend. I will post the assignment sometimes this weekend. I'm in the middle of putting it together now. Now remember, you have to have it done by Wednesday morning because the grades have to go in Wednesday. Got it?
Yes.
Got it.
Yeah.
Yes, sir.
Okay. Enjoy your weekend, guys.
You too.
too. Bye.
Goodbye.
You too.
Bye, guys. And peace, Kishan. Kishan. I didn't say that right.
Mr. Purdue. Oh.